One of my favorite scenes in Back to the Future 2 is when Marty McFly basically goes to this little girl and steals her hoverboard. What really got me excited was just being able to hover above the ground. And that's actually possible through something called acoustic levitation. Acoustic levitation uses sound waves, which are longitudinal waves. But what's that? Well, notice what happens when a rock is dropped in a pool of water. The vibrations that are created emanate outwards, but stretch back in. This is just like how sound waves stretch air molecules, since once being stretched, air molecules want to return to their prior state, so they begin to compress inwards, like how a spring may stretch but eventually compress to attempt to return to its initial state. And we can explain that process with something called a slinky. Now here I'm going to attempt to push and then pull onto the slinky. This will allow us to see a pattern that is very similar to a sound wave. The first pattern has the compressed spring in the middle when the springs from the left and right push inwards. Let's call these compressed springs antinodes and the space between them with little to no compression nodes. You can see that there's another distinct pattern when there are two antinodes at the ends of the spring. Notice how antinodes alternate between high and low pressures, while the nodes stay somewhat consistently at a resting, little to no deformation state. As the antinodes alternate between patterns number 1 and pattern number 2, they create areas of high pressure. The way particles tend to move to lower pressure states is very similar to how introverts like me might move to less crowded areas. The more people there are, the less comfortable I become. The same thing happens with particles that try to avoid areas that have a large number of condensed springs, which have relatively high pressures. As a result, the particles will be pushed towards the node. Sound waves are very similar in structure to the spring shown. By using a transducer and a reflector, the same process occurs and the particles can be trapped or rather levitate with ease. But are those the limitations of acoustic levitation? I challenge you to continue to explore.